Okay, 11 doesn't say anything about asymptotes. It does have the exact same wording as the buff packet. It says to analyze the continuity. So on the buff packet, this is what you would have done. You would have written down right away, we need to find the limit as x approaches 0 from the left of this formula called f. That's exactly what you would have written. So write that down. It's exactly like the buff. I'm going to give you a shortcut. I assume that you're like me, that you prefer to write as little as possible, but still make sense of it. So I'm going to tell you that on the AP test, if you are given a formula that is not piecewise, so the buff packet had piecewise formulas where you have multiple formulas. So you have a non-piecewise formula. You don't have a graph. That means that the left-right limits are about 99% of the time going to be the same. So we're going to do a little shortcut here. We're going to just put a plus minus, and we'll do the left and right at the same time because we're kind of guessing that they'll come out the same. There will be cases where they won't, but they're so infrequent that we can kind of deal with those when they happen. But to save some writing, we'll just do the left and right at the same time. Okay? Questions so far? Please.
Wait, so if they're not the same, but you like do it this way, like say that they are beginning, will you find out later?
Gotcha. No, it's a good question. Two more for Sophie. So what's going to happen is, I'm having you write the plus minus, Sophie, just so you don't forget that we're doing left and right. As we get a few steps in, there'll be a place where you go, oh, wait a minute. This time the left and right turned out to be different. So it'll kind of catch you. As long as you keep remembering you're doing left and right. What I worry about is if I don't have you put this little extra plus minus, you'll fall into the trap of thinking you're just dealing with 0, and you're not. You're dealing with a little more than 0 and a little less. So the plus minus is just a reminder that, hey, we're doing both. Does that help? Cool. Also, to be honest, this plus minus is not legal notation. So after a couple of days of kind of practicing this, or I'll stop writing it. I'll just expect you to remember that that really means do both. Because you can only find the overall limit by checking left and right. So, solid? All right, so I'll put it here for today just as a reminder, but really we'll stop writing it soon. So, okay, just say yes or no. Do we perform step 1? Yes or no? Say it. Again, do we perform step 1? Yes or no? Say it. That's rough. The first step says only if x is approaching positive or negative infinity. We're not. We're approaching 0. So you must ignore step 1. You must ignore step 1. Class didn't seem really confident on that, so we had to just tell you. But any questions? Just ignore step 1. Okay, cool. Step 2, factor and divide. Okay, please note, it says and. It's reminding you that you must do both. If you can't factor and divide, there's no reason to factor. So we'll encounter problems where I'll say, oh, no sense factoring because we're not going to be able to find a factor on the top that matches a factor on the bottom, so it's a waste of time. But in this case, you can. So this limit's going to equal the limit as x approaches 0 from either side. And now instead of writing f, we're going to write this formula, but we're going to factor this formula. You want to do easy factoring first. So that means let's pull out an x squared. Because I can see that I'm going to be able to pull out an x squared on the bottom as well. There's no reason to factor if I can't get a factor on the top that matches a factor on the bottom. I could have pulled out a 3 on the top, wouldn't have made any difference because there's no 3 on the bottom. So you can pull it out if you want, you don't have to. Plus it's just a constant. So questions? So hands up, who knows what goes inside the parentheses on the top now that we factored out an x squared? Everybody knows what's going to go in the parentheses in the top. Hand is raised. You get 2. McKenna, what goes in the top?
3x squared plus 12.
3 for McKenna. Anyone have a question? Solid. What's on the bottom? Hands up. What's on the bottom? The point, if your hand is raised, will go to Elise.
1 plus 6x.
3 points for Elise. Questions? Cool. In the last limit, we asked some questions about the formulas. We've got a green formula, we've got a blue formula. Please raise your hand if you can tell me if they are the same or different. Like we did this on the last question, doing it again here. Are the blue and the green same or different? Point if your hand is raised. We'll try Jackson. How about?
They're the same.
This time they're the same. We didn't discard anything. We just factored so it looks different. But they're identical formulas. Because we're not approaching infinity, we're approaching 0. How many new? Point. 2 more for Jackson. Questions? Awesome. All right, next step. I'm just going to take advantage of the fact that I'm dealing with factors. So I can, like I said to Spencer previously, I can write them in any kind of order I want. So I'm going to write x squared divided by x squared multiplied by 3x squared. This step is not strictly required. I'm just doing it because some people can see more easily once I write it out. But you could have done the same thing on this line without really writing anything. So I'm not bothered by anything. Super cool. Let's see. If x is almost 0, raise your hand if you can tell me the value of the yellow box. Listen carefully to the words. If x is almost 0, meaning x is a little more or a little less than 0, what will be the value of the yellow box? Hands up. Don't overthink it. If x is almost 0, what is the value of the yellow box? Okay, point if your hand is raised. Tyler, what do you get?
0.
So it's not right, but tell me why you thought 0.
Well, because if it's like almost 0, 0's, oh, frick, 1.
Say again?
1.
And why is it 1?
Because isn't 0 squared 1?
Oh, my bad. So let me.
Is that what you just said?
Here, hold on. I heard your last statement. Say it again.
I said 0 because 0 is 0.
3 points. Let me clarify. If x were exactly 0, the top would be 0. That was correct.
Yeah.
If x were exactly 0, so would the bottom. Something divided by 0 is undefined.
Oh, yeah.
So we wouldn't know. But we're doing a limit, so we're really not plugging in 0. We're plugging in a number more like this, like negative 0.001 or something. And then like positive 0.001. If we do that, I don't know what we get when you square that number, but whatever's on the top is going to be exactly the same on the bottom.
Yeah.
That'll equal precisely 1.
Yeah.
So if I plug in something, 3 points for Tyler, if I plug in something other than 0, the yellow box is always 1. It actually doesn't matter what you plug in. Plug in 5,000 if you want. The yellow box is going to equal 1 unless you plug in 0. We're bothered by that. That's going to happen all year again, that little yellow box thing. So it's not just this unit. It will happen all year. Every good? Cool. So as x gets close to 0, yellow box gets close to, well, not doesn't get close. It is 1. Hands up, everyone. What will purple box be close to equaling or exactly equaling when x is almost 0? For hands. Just do the math. You can do it. What's the value of the purple box when x is almost 0? Wait for a few more. Get more of most people. Talk for a minute. I want to get everybody to raise their hand. What's the value of the talk to each other, figure it out. What's the value of the purple box when x is almost 0? Just the value of the purple, just the purple. That's the value of the purple box when x is almost 0.
Yeah, this was open.
Hands up again, hey. See if that helped anybody. See if you got anybody who didn't have their hand up who now has their hand up. A few people dropped out, like they were more confident before they talked. It's okay. So, let's go Sawyer. What do you get for the purple box, Sawyer?
12.
So when x is really, really close to 0, this goes back to Sophie's question. When x is close to 0, Sophie, will this item here, what will this be equal to, Sophie, when x is either a little more or a little less than 0?
You're right.
It's going to be really close to 0 because close to 0 squared is close to 0. Close to 0 times 3 is close to 0. Doesn't matter if I'm a little less or a little more than 0. Okay, 3 points for Sawyer, 3 for Sophie. Plus 12 means the top's getting really close to 12. So if you were doing a table of values like this, and you were plugging in close to 0, the y value would be very close to 12 on the top, other than the bottom yet. Because the yellow box is precisely 1, and they're multiplied. I'm bothered by that. The logic has to make sense to you, otherwise you got to talk till I can help you make sense of it. Okay, what's this box going to equal? Green, hands up. When x is almost 0, hands up. What will the green box equal when x is not 0, but x is very, very close to equaling 0? So Austin Tolman?
1.
So this one will be very close to 1, not exactly, but very close. So we could put a 1 here, and a 1 here. Raise your hand if you knew it was 1. Point, 2 for Austin. Questions? Solid. So we found the limit. Excuse me, we found the limit. The limit is not approximately 12. The limit is exactly 12. Because limit means what are we getting close to equaling. And as I was trying to explain to Sophie earlier, it didn't matter whether x was slightly more or slightly less. We needed to check both. That's why your flashcard says check left and right. So we've done that. We hit no issue. That limit is 12. Questions? Solid. Just like the buff, though, now what do we do to continue our analysis of the continuity? Like right here, this number, we have found the left-hand limit to be 12. We have found the right-hand limit to be 12. Therefore, we have found that the overall limit is 12. What is left to do to analyze the continuity? Everybody, come on. It's from the buff packet. Get your memory to kick in. Just like you did in the homework, what's the next thing you would have to do if you're analyzing the continuity? Get most everyone. Try to call on somebody new. Let's go, Ariel.
Would you just find, like, if the limit's 12, you just find like the left and right of it?
Oh, stay with me. If your hand is raised, give yourself a point. Ariel's going to get 3. We've actually already done that. We just kind of did it all at once. We said, hey, left limit's going to be 12, right limit's going to be 12, overall limit's going to be 12. We're still missing something, though, to finish our analysis of the continuity. Who knows what we're missing? Hands up. Another point if your hand is raised. Josh, please.
Because we know that the left and the right limits are the same, it means that it is continuous at 0, x equals 0.
3 points. He's still missing something. What are we missing to finish our analysis of the continuity? That's better. Let's go here to Levi. So over.
Would you just plug in 0 for x?
So what do I write, Levi? Because I gotta have the right notation.
It'd just be f of 0 and then.
There we go. I've got to go find f of 0. Okay? If your hand is raised, point, Levi gets 3. Okay, to find f of 0, I can use the green formula. I can use the blue formula. Or I can use this red formula. They're all the same formula. Choose whichever one you want. I think red is best. And here's the key. Raise your hand if you know what the yellow box is equal to when x is precisely 0. We've already said it once today, so I wanted to make sure you know it. What is the yellow box going to equal when x is not close to 0, but x is exactly 0? For hands. Here we go. Point if your hand is raised. Izzy gets 3.
Non-existent.
Right idea, they'll say undefined.
Oh, I'm fine.
Because we're doing a function's value, not a limit. But right idea. So this is undefined. Because the yellow box would be undefined. And undefined times something else is still undefined. Questions? Then you write the conclusion, just like you did on the buff packet. So you write, here's what you should be thinking. You should be saying, okay, my left-right limits were the same. They weren't different. So if my left-right limits were different, I either have a jump or a vertical asymptote. But let's see, my left-right limits didn't go infinite, so it's not a vertical asymptote. They're not different, so I don't have a jump. They are the same, but they're different than the function's value, so that's a removable discontinuity. So you say since the limit as x approaches 0 for the function f is not the same as the function's value at 0, the function has a removable discontinuity at an x-coordinate of 0. We want to talk about that. Yeah, please, Sydney.
Are there certain times, like, when you just say f of x has a removable discontinuity, or when you use, like, the therefore symbol, or does it not matter?
Oh, that part's not really that critical. You're kind of free to write whatever feels good. I was teasing first period today. I said, literally, if you wrote the limit, the limit's different than the function's value, and then you just thought it'd be clever, you wrote, so any fool can see that that's fine.
Okay.
It doesn't really matter. So, they'll take whatever. So, good question. Anybody would know. Like, isn't it obvious? Like, why are you even asking? Okay. Anybody else? That's a famous joke from college textbooks where you're following the work in following the work in a textbook, and they get to a certain point, and then they go, and it is patently obvious, and then they show some result, and you all look at it like, how in the world did they get from here to here?
Sorry, saying that the limit is at 12, but there's a, like, removable discontinuity at 0.
Let me draw a picture that might help. So, 3 for Elise. If this were a graph of f, Elise, this is what we would have discovered with our analysis. That near x equals 0, like either slightly less or slightly more, the y-coordinate is very close to 12. So something like this. When we're close to x equals 0, both y-coordinates are infinitesimally close to 12. You okay with that? When x is precisely 0, there is no y-coordinate at all. It's missing. It's been removed. So the name they give to this occurrence is they call it a removable discontinuity when x is 0. Did I answer your question? Good point. Okay.
What's L'Hopital's rule?
Gotcha. Anyone speak French? Can't speak a kind of French? Most French? Pointing to Sienna that speaks French? No? Kind of. I thought it's pronounced L'Hopital, but if I'm wrong, please correct me. So L'Hopital's rule won't show up until February, but it's really works well for me to give you the flashcard with it on there, so that you kind of just get it in your head that eventually you're going to have to consider using L'Hopital's rule. But for now, we won't use it at all until about February. So, good question. Anybody else, please?
When you're doing that second limit, yeah, that one, do you plug in both the close to positive 0 and close to negative 0?
Yeah, that's this step right here, 3 points for Jackson Howell. And it's what I was warning Sophie about. You've got to remember to check both a little more and a little less than 0 and get comfortable with, hey, I'm getting the same result either way. Then I know the overall limit is the same. There will be those few exceptions where suddenly that's where you'll notice the difference. You go, wait a minute, if I plug in a little more than 0, I get something different when I plug in a little less. So now I have a left-right limit that is different, which means I have a jump. Unless they're going infinite, then I have a vertical asymptote. So. Or, yeah, please, Nick.
So you said that like with this kind of problem where there's only one option kind of different than last homework, you said that they're like as it approaches positive and it approaches negative, they're usually going to be the same. So they're not really jump discontinuities for these kind of problems.
Yeah, let me summarize that. 3 points. For our AP test, 99% of the time, there are exceptions, but it's rare. 99% of the time, if they don't give you a piecewise function, piecewise was this style here, like that's a graph, but like a piecewise function like coming up, come on, one more, like that.
Okay.
That's a piecewise function. For our class, 99% of the time, the only time you have a jump is if it's piecewise, or if the graph clearly shows that it was piecewise, and therefore you can see the jump.
Okay.
Otherwise, we don't typically deal with jumps, except for a couple of rare cases I will show you later. So.
Okay.
Does that help?
Yep.
It's good work. Anybody else? Cool. All right. Any other questions here? Nicely done. Good discussion. Stop this video.